Hi, I'm Idolis H. Paulo, 16 years old and a grade 11 student from Rizal National Science High School.
Hi there everyone, my name is Michael L. Illustre, 17 years old student from Rizal National Science High School, a grade 11 student of Isaac Newton. I'm now here in front of you all to present implicit differentiation. So, what is the purpose of this video? The purpose of this video is to help other students to illustrate and solve problems of implicit differentiation.
In this tutorial, we define implicit differentiation. Then, using several examples, we demonstrate implicit differentiation as a method for finding the derivatives of a function that is defined implicitly. After working through these materials, the student should be able to find the derivative of an implicitly defined function using implicit differentiation.
Our lesson for today is about illustrating and solving problems using implicit differentiation. But before starting our lesson, let us define what implicit differentiation is. According to Merriam Dictionary, it is the process of finding the derivative of a dependent variable in an implicit function by differentiating each term separately. By expressing the derivative of the dependent variable as a symbol, and by solving the resulting expression for the symbol.
So the first problem that we have now is y is equals to the square root of 2x minus 1. And the first thing that we need to do is to transform it into an exponential form, which can be written as y is equals to 2x minus 1 raised to 1 half. And then the next thing that we're going to do is to find the derivatives of this function. We're just going to apply the rules and 1 half minus 1 times 2x minus 1 is equals to 2. After we get the derivatives, we're going to simplify it, okay, so that we can be able to find the value of dy dx. 1 half times 2 times 2x minus 1 raised to negative 1 half, or simply equivalent to the square root of 2x minus 1. This is now the derivative or using implicit differentiation. dy dx is equals to 1 over the square root of 2x minus 1. So the second problem that we have now is xy squared plus 2x minus 3 is equals to 1. We will differentiate them again. Don't forget to write dy dx after you differentiate a term that involves the term y. Next is we are going to simplify them. 2x times 2y can be written as 2xy dy dx plus y squared plus 2 is equals to 0. Now, we are going to combine like terms, and we will leave the term with dy dx on one side of the equation. So I'll just leave it here. 2xy dy dx is equals to, we're going to subtract y squared and 2 from this side so that it can be written on the other side. I will simply transpose it. After this, we need to remove all the coefficients and variables beside dy dx. So we're going to divide both sides by 2xy. So dy dx is equals to negative y squared minus 2 all over 2xy. This is now our second solution. The dy dx is equals to negative y squared minus 2 all over 2xy. So for our third and last problem, we have x squared plus y squared is equals to 16. And the first thing that we need to do is to find the derivatives of this sample or to differentiate that. Please take note that we differentiate a term involving y. So we're going to write dy x equals to 0. Then we will simplify this expression by separating unlike terms. So we're going to add negative 2x to both sides, or we will just transpose this term. So we will cancel this out, and we have now 2y dy dx is equals to negative 2x. So the next thing that we're going to do is to divide both sides by 2y, since 2y is the term beside dy dx. Divided both sides with 2y. So we have now dy dx is equals to negative 2x over negative 2y, and this is factorable. Our final will cancel out 2, and we will have negative x over y. So this is our final answer for this problem. dy dx is equals to negative x over y.
To summarize our lesson for today, there are two steps in solving implicit differentiation problems. The first thing that we need to do is to differentiate each term with respect to x. Be careful in differentiating each term and remember the rules applied. Also, it is important for us to remember to write dy over dx if the term that we are differentiating involves the y term. The second thing that we need to do is to solve for the dy over dx and simplify the terms. Combine all the terms with dy over dx on one side of the equation. Remove all the coefficients and variables beside dy over dx. Then simplify the terms if possible.
So now that we're done showing you the process on how to solve problems involving implicit differentiation, it's your turn to solve problems and apply what you have learned today. Thank you for watching.
Video. We hope that you learned something from us. So, thank you again, and bye-bye!